I'm delighted to be in Paris. I think it's the second time I have been in IAP. So today I'm going to report what we are doing on free-floating planets with two ongoing surveys, KMTNet and DREAMS, and the future space satellite project called ET. So most of the work has been done by ex-students or current postdocs, Wei-Sun Zhang, Hongjin Yang, and Qiu Qian, together with KMTNet team, DREAMS team. I think a few of the collaborators are here. Sanju, Sean Terry, and Etin, and also some other members. Okay, so, well, it doesn't work. Let's see. So I think Taka gave a wonderful talk about the free-floating planets. I think it's very important to realize that this mass function is based on only very limited number of free-floating planet candidates, only a dozen or so, and the mass function has large uncertainties, and I think it's also very difficult to explain this population, particularly at the low mass end, based on a number of theoretical studies I have listed here. Okay, so for KMTNet, it's important to realize that for the 10 or so cases of free-floating planets with finite source size, as mentioned by Taka, so below 4 microarcseconds, you have some candidates from Mo and some candidates from OGO, but there are no candidates from the KMTNet, which I think is current world leader in discovering extrasolar planets. And it has 3 sites from Chile, Australia, and South Africa. It has 4 square degree large field of view with a high cadence about 15 minutes. So it's expected for such a survey that you can discover actually free-floating planets with lower finite source size as listed here. So why is KMTNet not discovering these candidates? And the reason is very simple. So for the pipeline used by the survey, so-called full-frame difference image pipeline, it actually has large error bars and many outliers. So it's not very useful to identify very short and low amplitude free-floating planet events. And the PhD thesis of Hongjin Yang was to develop a new pipeline, which he succeeded. And you can see for the same event, the light curve is much more smooth and you have fewer outliers. So this is extremely important for searching for free-floating planets. And this is the current thesis of Qiu Qian at Tsinghua University, trying to use an updated pipeline to search for free-floating candidates in the KMTNet database. So, in fact, she found some interesting events. So one is shown here. You can see some light curve features lasting for about 2 days. But it turns out from light curve modeling, this is actually a short time scale, high prob motion M-dwarf binary event, not due to free-floating planets. So, so we have done detailed simulations with less error bar from KMTNet, and we found that for stars with different magnitudes, we can actually reach a much lower finite source effect. So lowest one is around 0.5 microarcsecond, the peak is around 1 microarcsecond. And this is very important because with lower detailed measurement possibilities, you can probe a free-floating planet population to lower masses from Jupiter, Neptune mass to perhaps 1 Earth mass, or even a bit lower. Now, the expected yields, so Qiu has done detailed simulations, and we expect in the 8-year and 12 the square degree high cadence fields, we should see about 30 to 50 free-floating planets. So currently, she is searching in 1 square degree with 8-year data. So far, she has not found any event in 1 year, but in principle, she should find she should find maybe a few events in 80 data she is currently analyzing. And I promised her that once she finds 5 events, she can get her PhD. So in fact, we can think about what we can do from the ground. So for KMTNet, it's 1.6 meter telescope with 15-minute cadence. If we can use larger telescopes and high cadence, for example, on a 4-meter class telescope with 2-minute cadence, and the sort of light curve we see from KMTNet will become something like that. So this is for one free-floating planet with Mars mass. So you can see the signal-to-noise ratio here will be much, much higher. And this is exactly what Hongjin Yang and Wei Shenzhang have proposed to use with the DECam on 4-meter Blanco telescope in Chile. This proposal has been funded with about 80 nights between 2025A to 2028B. And so this is the field this survey, so-called dreams. So I thought these young people should have dreams. So I made up this name. That's my only contribution to the work I'm going to describe later. So this has a 3 square field view, and it has 1 overlapping square degrees. So the cadence is 2 minutes for these fields, and for the overlapping field is about 1 minute. So it's done in 2 colors. In Z band, it's about 80% of the time, about 20% of the time is done in the R band. So in comparison, KMTNet has a 15-minute cadence, as I mentioned. So because of this, with higher sensitivity, high signal-to-noise ratio, and also much higher cadence, so KMTNet can reach around Earth mass. But if you go to dreams, you can go to lower masses all the way to the moon, as you will see one example later in simulated event, and detect more candidates. Because if Taka is right, the mass function rises very sharply. So at low masses, you have many more events you expect. Okay, so this is actually the image we see from our July campaign this year. It has 9 nights with about 2,200 exposures. So we detect about 10 to 8 stars in these images. So we have done detailed simulations, what we should discover if Taka is right, using the speed rising mass function. So you should peak around Mars mass and sensitivity all the way to Moon's mass. So you should discover about 120 free-floating planets. And this is done using 80 nights on ground-based facilities. And so this is extremely cost-effective. Okay? So we expect a data release in early 2026, early next year. And as I mentioned, we have about 10 to 8 stars. And this data set will also enable a lot of other science like ultra-compact binary, variable stars, transit planets, asteroids, all these things. Different things which I'm also quite interested in. Okay, so what have I found so far? So this is actually not a free-floating planet, but a bound planet using KMT data. It has 2 degenerate solutions, so-called wide resonance and closed central, but with the high cadence, the high photometry of DECam, you can see only 1 solution survived, the black one, the resonant caustic. So it shows the better signal-to-noise ratio and highest cadence is really important for understanding not only free-floating planet, but also for bound planet population. Okay, so using real error bars in the database, we can simulate whether we can see a free-floating moon using the current data quality, and you can clearly see you can do this with very high signal-to-noise ratio. So we're very excited about this possibility. So with minute level cadence, you can actually see something you may miss with a 50-minute cadence. So this is what you will see with the 50-minute cadence. You may think, oh, this may be a free-floating candidate, but in fact, with the 2-meter cadence, you can see it has sharp rise and slow fall, so this is clearly stellar flare. In fact, in the current database, we have found that we have about 200 flares, 2 to 3 free floating candidates, and you will see later on the number has been reduced by 1. So the flare rate is about a factor of 100 higher than the expected free floating planets. So as Taka mentioned, this is the main contamination. So not only we have single flares, we have double flares, as you can see here. So we can see microlensing event, at least candidates. So this is source magnitude 22 magnitudes, and this is very difficult to see in the KMT database. It is too faint. So this is one free floating planet candidate. As you can see, it shows some finite source size effect. So I was very happy sleeping last night, but about 15 minutes ago, I was sent this figure by Hongjin Yang. So it shows that this is Z-band data, and you have also CFHT data R-band. So you can see this is clearly a flare with high quality data from CFHT. And the reason CFHT data is high because it has better seeing. So you can achieve better data quality in terms of for this event. So clearly this is a flare. So this is a word of caution for searching for finite source size free floating planet candidates. Okay, so now I come to the space satellite. I think already we are very clear that microlensing is degeneracy. So we can, from fitting the light curve, we can infer how long this event lasts and also measure the Einstein radius angular size. But we don't know because of mass degeneracy. If it's in the disk, it may be a Neptune. If it's in the bulge, it may be a Saturn. And the mass uncertainty factor 5. And as Sean Terry showed in his event, the uncertainty also around the factor 5 to 6. So how to remove this degeneracy? I think this was also discussed by Taka. So we use space satellite. And this was convincingly demonstrated by one event discovered by Subo Dong from Peking University in China. So he has used Gaia satellite to detect a free floating planet using the space satellite to determine its mass uniquely. So this really demonstrates the power of space satellites. So what we hope to do with the Earth-2 mission is combining the KMTNet and also the Earth-2 satellite in space to do this. And we have done detailed simulations for one Earth mass planet. This is what we will see from the satellite, and this is what we see from the ground. So the best distance is really between L2 and Earth, because this is roughly the size of the free floating planet Einstein radius. So let me just use one slide to demonstrate what is the Earth-2 satellite. So it has 6 transit planets, transit telescopes, about 28 centimeters, has a factor of 5 larger field of view than Kepler. And this, so these 2 telescopes are microlensing telescopes with aperture about 35 centimeters. And there are 2 because you have to change the direction every 3 months also due to the orientation. So it will co-observe with KMTNet, and the PIs are the 2 names as listed there. So it will launch in October 2028. So this will be about 2 years later than Roman. So we have done detailed simulations, or they have done detailed simulations in the last few years. For example, how the image quality degrades as a function of time because the CMOS detector changes, and also the cosmic ray may fluctuate as a function of solar cycles. And we have demonstrated that we can achieve the required signal-to ratio. For example, 20.5, it should be 5, and at 16, about 80. And you can see the parallax signatures from space and from the ground. So in the end, let me give one paragraph summary. So ET expected to detect a few hundred free-floating planets, and about 1/3 of those will have mass determinations using the space satellite. And we promised the Chinese government that if the mass function is correct, we can detect 25 free floating Earths. Okay, so this is again assuming the current mass function is correct. Okay, so this is actually the discovery space of ET transits, microlensing planets with bound planets and also free floating planets. And you can see, as will be done Roman by Roman as well, you can cover the whole parameter space of period and mass in a single satellite. So this is our dream. Now, let me come to the summary before I show some commercial. So this is what we'll do from the current two ongoing surveys, KMTNet and DECam, covering different space, parameter space in terms of mass and numbers. So with ET, you can discover and determine the free floating mass much more accurately. Okay, so the final goal, of course, is to use bound planet population and free floating planet population to really constrain how planets form and evolve. Okay, that is our goal. So in maybe last one slide, let me show. Other than doing microlensing, I'm also recruiting for Westlake University. So this is a new type of university. So it has about currently 280 faculties. So my job for the next decade is to recruit about 20 professors. And in the current year, we are recruiting 9 postdocs, including some in gravitational microlensing. And this university was at least on the online cover page of New York Times. So it must mean that this university has huge promise. Even New York Times noticed. Okay, so let me put up this slide and stop here. Thank you.
Great talk. So you predicted for dreams that you would find something like 100 free-floating planets, but you only have 2 candidates based on these recent results. Does that say anything about whether the power law is holding into this new regime?
That's a very good question. I don't know the answer because we have only done about 9 nights so far. And we are still analyzing the data, and we are very worried about these contaminations. So we want to make sure every event is real by combining DECam Z-band data and I-band data. And we also have some ongoing CFHT and hopefully SILBRU data to confirm the true nature of these free-floating planets. But that's a very good question. As a theorist, I'm a little bit worry that whether we can produce a large number of free-floating planets. And I think we'll hear many talks in the next few days about this.
Awesome talk, Shude. I had 2 quick questions for you. So your number of 30 that you were telling Chu she's going to find, how did you get that? Was that from Taka's mass function?
Yeah, we are using similar mass functions, yeah.
Okay,
and then using real data, error bar, something like that. Yeah.
Okay. And then the other question I had for you is the DREAM survey is really awesome and is, funded through 2028. How much of it will actually overlap with Roman so that you might be able to get these parallax measurements?
Well, Roman is supposed to be launched in September 2026, right? And how much overlap?
I don't remember, but it depends on when you're observing, right? Because remember, we're looking around the equinoxes. So as I remember, there wasn't a lot of overlap in terms of time, but I think that's right. But do you know when the survey duration of dreams overlaps with the Roman season?
I'm not sure about that, but anyway, the KMTNet will cover the most 4 Roman fields. But we didn't decide yet. Our cadence will be changed with the same as the Roman, not yet.
Do you know the answer to this, Matthew? Is that why you're raising your hand?
Well, I don't, but it's still negotiable with Noir Lab. So I think once the Roman dates are fixed, they will be reasonably accommodating to get as much time as possible overlapping.
I think now I remember the overlap is not huge.
Right.
That's my impression.
That's my recollection. Yeah. Okay, one more, Sean.
Hi, great talk. The recent news from Hongjing that reduces the yield by 1. So the current yield of the candidates is 1 or 2, but I noticed you didn't show the 1 or 2. Do they look good?
I think Weicheng and Hongjing are still analyzing the events, so I think it would be premature to claim any definite candidate, especially given the history of this. I was quite excited to see at least some potential candidate, but then once you have better seeing, this sort of thing really becomes more complicated to interpret.
Thanks.
Okay, let's thank our speakers again.